Hi Geometry, welcome back. I hope you've had a great week as you jumped into proofs. Proofs are something that you either love or you don't love, right? So I hope that proofs are really stretching you to think about the whys. You know, it's not enough just to say, well, because I think it should be right? So in proofs, we actually have to say whether there is a math reason that can validate why we're solving that way. Now, I know all of you love in proofs the first statement, statement one, the reason is always given, right? So it's whatever the book gives us as a fact. One angle might be 90 degrees, and then we say given, that was what was told to us. Now we might have to prove something else based on that fact. So that's why it's important to read through what the question's asking us, what it's telling us, what's given, right? And then from that, making reasons based on its definition, based on theorems, or even we can take facts that we're able to derive from that. So geometry is very reasonable and something that certainly makes us think. Now we're jumping into lesson 28, and we're looking at some triangle congruence. Now, lesson 27 that we started out was our two-column proofs, and we looked at that last week. And we also looked at side, side, side last week. So we understand that if three sides are congruent to another triangle, same three sides, then the entire angles are congruent. And then we also learned about CPCTC. Now that sounds a lot of fun, doesn't it? But it simply stands for corresponding parts of congruent triangles are congruent. So if I know that side, side, side is congruent to side, 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 then I know that those two triangles are congruent. So the top angle is congruent to the other top. The lower base, lower base. So those are the corresponding parts. And we remember an important fact that we discussed last week that you're going to hear me say a lot is order always matters. In geometry, you can't just throw up ABC is congruent to blah, 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 blah. You got to know that A is congruent to the first one and B, whatever is the second. And that order matters. So that's super important, especially when you're taking standardized tests. Have you ever seen it when they take a triangle and they flip it and rotate it, and you're kind of having to turn your head and going, well, if this moved to there, what would it be? Well, if it gave you a fact statement, given that triangle blah, 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 blah is congruent to triangle blah, 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 you don't even have to turn your head and move. You just have to remember that in math, order always matters. So whatever they said blah, 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 blah was congruent to blah, 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 blah. The first is the first, the second is the second, the third is the third. And so it really simplifies future learning because you know you can depend because order does matter. So today we're looking at side, angle, side. And what that would look like is if I have a triangle and I tell you that it's congruent to another triangle, if this side is congruent to this and this base is congruent to this, and I tell you that this angle is congruent to this, then I know based on side, angle, side. And one thing I want to point out to you that the angle has to be between the two connecting the two adjacent sides. So it's not just here and here, but it's the angle in between those two adjacent sides. So side, angle, side. Then that means that these two triangles are congruent. And I can know that that means all are. So that means that this would have to equal this. And that's based on CPCTC. So it's side, angle, side, and then everything else would relate as well. So that's very important to understand. So we call that side, angle, side. And the angle has to be between the two adjacent sides. So your book is giving you examples there of what you can do with that, because if you've got a variable, an unknown side, but you know that they're congruent, you can use side, angle, side to prove that. So example 4, it gives you a proof with side, angle, side postulate. So look, that's on the bottom of page 176. And it says given side AB is congruent to side DC. All right. And so then that's given, and then angle ADC and DAB are right angles. Now, because those are right angles, are congruent, then I know that the angles themselves are congruent. If they're both 90 degrees, then I know that they're congruent to each other. And that you could just write the definition of right angles, or you can just write right angles are congruent. That's what they put as example 2. Now it said AD is congruent to AD. Now we know that that's the reflexive property. It is what it is. If I look in the mirror and I see someone other than myself, that mirror, something's wrong with it, right? I am who I am. So that side is congruent to itself, right? That's the reflexive property of congruence. And then I know that triangle ABD, remember order matters, ABD is congruent to triangle DCA. How do I know? Side, angle, side. We already knew the side that was given. They also told us that 2 were 90 degrees, and then we knew itself is equal to itself, so that has to be side, angle, side. Now, based on that, then I know everything else is congruent as well. And if I had another side I had to prove, I could say, after I've proven that, I could say, based on CPCTC, corresponding parts of congruent triangles are also congruent. Now, look at page 177, our lesson practice. Determine whether the pair of triangles is congruent by side, angle, side postulate. So take a look. I've got one etch mark, an angle, and then 2 etch marks. One etch mark, an angle, and 2 etch marks. So it's the same, they've just turned them, right? So letter A would be, yes, side, angle, side, because the angle is between the 2 corresponding sides. Letter B, find the value of x that makes the triangle congruent. So they've given us side, angle, side, and then they've told us the 2 angles that correspond between the 2 adjacent sides that are congruent and they've given us different values for each. So since we know they're congruent, we set them equal to each other. It says 3x minus 12 equals 2x plus 8. So 3x minus 12 equals 2x plus 8. I'm going to move the variables first. So I'm going to subtract 2x. 3x minus 2x is 1x. Bring down the minus 12 equals 8. I've got to get that variable by itself, so I'm going to add 12 to both sides. Remember, I have to keep my my equation balanced by doing the same to both sides. So x equals 20. So now it said find the value of x. Be careful, some story problems may say what is the actual angle. So then you would have to plug in x is 20 and find what the angle measurement is. So I've seen students miss that before by not reading the directions carefully. So be on the lookout for that. All right. Letter C says use side, angle, side postulate to prove those 2 triangles equal each other. And you're going to get to do that very similar to the example we just had. So I'm not going to take time to do it. But you do see that it's given the 2 things that have already said they're congruent. And then using the reflexive property W y is congruent to WY, and that's based on the reflexive property. And then you'll know that they are congruent, and the reason, side, angle, side. So letter C is a good way to rework example 4 that we just talked about. All right, and then letter D, a land dispute over 2 triangular parcels of land can be ended by showing that the parcels have the same shape and size. The 2 sides of each parcel of land were measured, and it was found that point C is the midpoint. All right, so it says in the dispute by proving this. So I'm going to let you do this on your own, but I hope you'll really, really think through. If something is the midpoint, it means it's exactly halfway. So you can use the definition of the midpoint to prove that they're congruent. Now, one thing I immediately notice is they're intersecting lines. So I know that those opposite angles have to be congruent. Do you remember the term for that? They're vertical angles, right? So I hope you remember vertical angles are congruent. So you can use definition of vertical lines. Now, also, you know that the C is the midpoint of the other 2. So I hope your wheels are turning. Are you knowing how you're going to prove those triangles are congruent? Is it side, angle, side? Good job, because the angle is in between the two sides that have the same midpoint, and you know that midpoint means that they are equidistant apart. So great job. So any of you that someday survey land, you'll be able to dispute that based on your smooth geometry knowledge that you're learning right now. All right, lesson 29. On lesson 29, we're going to jump into the Pythagorean Theorem. Now, I love the Pythagorean Theorem. No matter which math class you're in, a squared plus b squared equals c squared. Isn't that such a fun one? And we only can use the Pythagorean Theorem when we know it's a right triangle. I've seen students before see a triangle and start to use it, but remember, it has to be used only in right triangles. So if you're, don't forget that c has to be your hypotenuse. All right, and the hypotenuse is always the longest side, and it's always opposite the 90 degrees. Does not matter which one is A or B. We call those the legs, and it doesn't matter if you put this one in for A or this one in for A, doesn't matter. But C is always the longest, so doesn't matter. You can swap those and put BA or AB, but C always has to be opposite the 90 degrees. We call that the hypotenuse, and it is always the longest. All right. So if I ever gave you an assessment question and told you the hypotenuse was 10, but one of these sides was 13, you would immediately know, wait, that can't be. All right. Now your book also tells you about some common Pythagorean triples. 3, 4, and 5 are the most common Pythagorean triples. And a lot of times on standardized tests, they'll use patterns of that. Like they might multiply each of these by 2 and give you 6, 8, and 10. But they'll always reduce to 3, 4, 5. So like they might give you, let's say they said that you had 2 legs that were 24 and 32. If you see something in common, reduce it, and you know 8 will go into both of those. That reduces to 3 and 4. So you know it's 5. 5 times 8, this is 40. So you can easily solve those standardized test questions that typically use that Pythagorean triple if you can reduce it to 3, 4, and 5, and then just multiply it and solve. Now you can always say 24 squared plus 32 squared equals, and then get your answer and square root it. But if you know that Pythagorean triple, it just makes it a lot faster to be able to solve those. All right. Now your book gives you some practice with using Pythagorean triples to find the legs. So you would actually take c squared and subtract either a or b squared to find the opposite. So that's using your Pythagorean theorem. All right, let's take a look at practice on page 184. So page 184 says, find the hypotenuse of the triangle. Do the side legs form a Pythagorean triple? So you've got the picture on letter A is 21 and 20, and then it's asking what this is. And your book called this X. So we know it's opposite the 90, so it's the hypotenuse. So it's 20 squared plus 21 squared. Now that's not a Pythagorean triple because this reduces by 2, but this is divisible not by 2. So that's not a common Pythagorean triple, but it could work out to one. So you're going to have to, on your calculator, say 20 squared plus 21 squared equals, and then square root that answer for what your hypotenuse is. And notice it's opposite the 90 degrees, the right angle. All right, letter B. Find the value of P in the triangle at the right. Do the sides form a Pythagorean triple? Now, I've got, in this case, for letter B, this case, they have actually given me the hypotenuse. And they've said one of the legs is 40, and the hypotenuse is 41. It wants to know this. So you would actually say x squared plus 40 squared equals 41 squared. So when you're solving this one, you're actually going to take 41 squared and subtract 40 squared to get x squared, and then square root your answer to find out what x is. Now, if it's not an exact number, you're going to have to round that or leave it in radical form. All right, and your book gives examples of that on example 3 about simplifying the radical. And I know you did that in Algebra 1, but it's important that if it's not a perfect square, you're going to have to simplify it, reduce to lowest terms, right? All right. Letter C, find the value, and this time it is the hypotenuse. All right, another one, letter D, find the value of y in the triangle at the right. And that is a skinny, thin triangle, isn't it? But notice the hypotenuse would be 20. So it's 20 squared minus 2 squared equals the square root of y squared, right? All right, so you're looking for y. Now let's look at letter E. A ratio of a TV's width to its height is 16:9. If the width is 32 inches, what is the length of its diagonal? So you're having to think through the ratio of this, and then it's asking, so you're going to use that Pythagorean Theorem, a squared plus b squared equals c squared. So you're going to set up that ratio and then solve it. So I'm going to let you do that one on your own, but just to talk about the picture there is the ratio of width to, width to height. Right? So that's what your book is pointing out to you. And there's even an example on page 183, and they used TV aspect ratios. So they helped you set that up there. So letter E is just another practice problem based on their example problem. So I'm excited for you guys to have fun with your Pythagorean theorem, and especially as you have used that before. Now, lesson 30 is more about triangle congruence, just like we just talked about in 28. So you're now looking. So let's as we jump into lesson 30, let's talk about what we have learned so far about how I can prove a triangle is congruent. I can prove side, 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 and we talked about side, angle, side, where the angle is in between the two adjacent sides. Now, your book is actually showing angle, side, angle, and this side would be in between the two adjacent angles. So that's important. And then you could also have angle, angle, side. And sometimes we see that where they give you a 90-degree right angle and then another angle and one side. So that's the congruence that we'll see there. So there's more examples there, and I'm just pointing them out to you, and I'm going to let you do your practice on your own because there's only a few, and I think it's important that you guys understand this is just like you've been doing. Instead of side, 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 it's side, angle, side. So you're going to have a lot of fun with those. Now there's an investigation where it talks about the angles of polygons, and I want to point that out to you because I think that's very, very important, and we'll spend some time in class going over that. And then the last lesson that you'll cover this week is lesson 31, the flow chart and paragraph proofs. Some people do not enjoy just listing them. So you can actually write out, if I know this and this is given, then da da. And so your book shows you how you can do a flow chart. So you might see people who are presenting something to their company and they use a flow chart to point that out. So we live in such a great data age. So there's some great examples on page 198, 199, 200, and 201. Again, you have to give mathematical reasoning. So I want to encourage you with looking over these pages and spend some time, whether you want to write out those proofs, set them up in a table, or do a flow chart. So there's multiple ways. So I hope you have a lot of fun this week. Remember, proofs aren't our enemies. They're actually just stretching our mind and making us prove what we are saying are facts. And don't you wish the media had to do that nowadays with all that's going on? It's hard to know which scientists to listen to. So wouldn't it be great if they had a flow chart or a proof statement, right? Well, God bless you all, and I hope you have a great week. And I'm looking forward to seeing you in class. And don't forget your 4 lessons and your assessment this week. God bless you all.